Black holes are fascinating, both literally and as a subject of conversation. They're extraordinary in every aspect, and we always learn new things about them. Black holes are similar to any other object in space, but with an extremely powerful gravitational field. This is contrary to popular belief, which holds that black holes are like cosmic vacuums that suck in space surrounding them. But how are they created, and how do they die? You were at the correct place, so keep watching to learn more. There are certain things in the cosmos from which you can never truly escape: your ex-girlfriend, black holes, death, and taxes. In some circumstances, you may be even to have all four at once. Black holes are often depicted as unyielding creatures that stalk the universe and devour everything in their path, and their nicknames is well earned. Once you enter or cross the event horizon's terminator line, there is no turning back. Even light cannot escape their grasp. But in the movies, the evil monster has a weak point, and if black holes are the galaxy's monster, they must have one as well, right? First thing first, let's clarify this. Astronomer Mitzi Benz wants you to know that black holes don't suck. She claimed that these are not cosmic vacuum cleaners that are sweeping up everything. They just harness gravity in the same way as everyone else. So let's start over from scratch and define what a black hole is. A black hole is a region in the universe that is so large and dense that anything trapped in its strong gravitational attraction cannot escape, including the universe's fastest object, light, because light cannot exit the region. Or you might say that a black hole is a region where gravity is intensified to such an extent that nothing can escape from it, not even light. And why can't light escape, you might ask? Well, it's because of the mass of a black hole is very compact and dense, and once it has passed the event horizon, often known as the point of no return, outside observers like ourselves are unable to see the black hole. In other words, they are essentially invisible. So you might be questioning how we know they are there if we can't see them. Okay, consider it like this. Although the black holes are invisible to us, we can see them due to the impacts they have on surrounding matter and light that is passing relatively close to them. Simply said, around black holes, strange quantum and space-time events seem to happen, which have also been observed that the radiation emitted by the superheated stuff that is creating an accretion disk as it swirls around them. An accretion disk seems like something you may very well have inserted on a classic desktop PC to load an application. In essence, it resembles the Eye of Sauron in outer space. So let's move on to the black hole's life cycle now that we have explained what it is in detail. Underneath the complicated mathematical junction of gravity and quantum physics, theoretical physicist Stephen Hawking made an astounding discovery in the 1970s. Given enough time, black holes shine ever so faintly, and given enough more time, they inevitably dissolve. Wow, that's wonderful news that the monster can be killed. Yet how? Well, more on that later in the video, but first, let's talk about its birth before we talk about its death. Ironically, a black hole's life really begins with a death. Basically, when an enormous star explodes at the end of their lives, black holes are created, meaning after fusing hydrogen into helium and helium into various other elements, including carbon and oxygen, up to iron in the star's core, it is created. When a star at least 10 times as big as our sun runs out of fuel, it no longer has anything to connect them but a heavy metal heart. The core reaches the end of its existence and bursts, ejecting the outer layers into powerful bursts as it collapses in on itself. This explosion is called a supernova. The star will implode on itself to a very tiny size if it has enough mass. The gravity will be so intense because of its small size and massive mass that it will absorb light and turn into a black hole. Black holes can grow enormously large as they continue to absorb light and matter from their surroundings. Even other stars can be absorbed by them. This connection between the creation of a black hole and the demise of the star from which it was born is quite common throughout the universe. Black holes and stars have a strong relationship, particularly in regions of the galaxies where star creation is accelerating rapidly. Additionally, the creation of a black hole can aid in the development of a new star. It's not simply a one-way street. It is comparable to a batter's trade or the phenomenon known as giant recycling program. Think of it this way. The biggest stars in a group of newly formed stars explode towards the conclusion of their brief lifetimes, dying out. Additional gas and dust are compressed by the shockwave, and as a result, more stars begin to develop. The largest of them will then experience a brief life and explode, creating fresh shockwaves and initiating the formation of new stars. New stars are being born as a result of the death of old stars in a chain reaction. The universe is simply too impressive. Now, all that was just the formation of a stellar black hole. Now let's move on to a stranger subset of black holes called supermassive black holes. These ones are enormous creatures with a much less clear shape. They appear to have a somewhat different manner of development than their smaller counterparts and have been observed near the center of galaxies, including our own. In other words, a supermassive black hole is 1,000,000 or 1,000,000,000 times more massive than the Sun. But it didn't begin that way. Rather, it began very small. And based on what we do know, they appeared roughly 13 billion years ago and grew really quickly, i.e., we don't know about their origin very much at all. Another possibility is that supermassive black holes may have developed from smaller black holes that first emerged and then emerged in the centers of young galaxies. So based on what we previously explained, we assume you already understand that black holes don't just remain the same size forever. And now we are moving on from its birth to its growth period. They acquire their undeserved bad image because everything that falls into them cannot escape. Instead, it is absorbed into the black hole's total mass, which causes it to grow. Whatever enters a black hole, whether it is gas, a planet that was torn apart, or a star, adds mass to it. In addition, a black hole can grow by consuming matter, and it never denies a successful merger. Black hole mergers result in the union of the two unseen masses. The orbits of the planets in our solar system wouldn't alter at all if the Sun were to be replaced by a black hole with a mass equal to the Sun. We would still be doomed though, as the unexpected arrival of the endless nights would be disastrous. Even black holes will eventually pass away. These demons won't disappear into the darkness easily when they do, either. In the dying seconds of each black hole, a burst of fireworks will light up the cosmos, signaling the end of an era. However, you might be wondering how they can pass away. In any case, it occurs via a physics mechanism known as the Hawking radiation. Yet how? How does the Hawking radiation operate? The theory of general relativity is a very complicated mathematical theory. The theory of quantum mechanics is equally complex. The conventional response to the question how is a load of numbers, but that's not very satisfactory. It goes somewhat like this. All around the cosmos, neighboring pairs of subatomic particles are constantly forming. The pair normally collides and fades back into energy shortly after they emerge from the universe, with one half of the pair being a particle and the other being an antiparticle. One pair of these particles occasionally appears, with one going in and the other free to escape. The escape continues on its merry way as a regular non-virtual particle because it is unable to collide and disappear. The entire object can finally be radiated away if that procedure is performed repeatedly without more mass entering the black hole. The process would take a very long time to make a dent in a black hole though, regardless of its size. And did you know that in theory, anything can become a black hole? Crazy, huh? The only thing that separates a black hole from the Sun is that a black hole has a far stronger gravitational field since its center is formed of materials that are exceedingly dense. We are unable to observe black holes because of their powerful gravitational fields, which have the ability to even capture light. Theoretically, you could create a black hole out of anything. For instance, if you crushed all the material in our Sun into a region that was only 3.7 miles wide, you would have created a black hole as well as an exceedingly dense region. The same idea could be applied to the Earth or your own body. In theory, you could become a black hole while watching this video right now. However, the gravitational collapse of a very massive star, 20 to 30 times more powerful than our Sun, is the only known mechanism that may result in the formation of a black hole. So what are your thoughts on black holes? Let us know in the comments section down below. Thanks for watching, and I'll see you in the next one.